All right, let's do a review of orbitals and how to draw an atom. I know there was a little confusion in class about this. So what is an orbital? So in class, I defined an orbital as a region of high probability of finding electrons. Now, in an orbital, you can only have up to 2 electrons. All right, you can never have more than 2. So when I introduced this concept, I showed you this image here. All right, and we have a nitrogen atom. We have these electron shells, right? And on these electron shells, we have orbitals. So these 2 electrons are in an orbital. These 2 electrons are in an orbital. These other 3 electrons that are just by themselves, they are also in each additional orbital. This is a very simplified way of looking at orbitals. It makes it easy to look at them. But in reality, orbitals are not this simple, right? They actually make all these different complex arrangements around the nucleus depending on how many electrons there are, how many electron shells. So we get all these different shapes. I'm not going to go any further into orbitals because for the purpose of this class, I just want you to know what an orbital is and how to draw an electron. Or not, excuse me, an atom. So let's draw an atom. Let's start with helium. All right, helium's a pretty easy atom to draw. So this is a great question. I might ask you something like this on an exam, right? I might give you an image of what helium looks like on the periodic table of elements, right? And the key number here is that number 2. That number 2 is telling me I have 2 protons. So I'm going to go ahead and draw in my protons. I know they have a positive charge, so I'm going to add little plus symbols on each of my protons. Because I have 2 protons, I know I also have 2 neutrons, so let's go ahead and draw those in as well. Now I need to add in my electrons, so I know I'm going to have an electron shell, so let's draw in my electron shell there. Now I also know 2 protons, 2 neutrons, I'm going to have 2 electrons. Now, if I look at the information given to me, and I will always give you this type of information, I will never assume that you automatically know how many electrons should go in each electron shell. So if I look at my information here, my first electron shell, I can see that for the number of electrons it can hold is 2. All right, well, that's great. I only have 2 electrons, so I could draw them in like so. Now, if you drew it like this, that would be quite fine. Right? I would not dock you points for drawing an electron like this. However, you might also see it drawn like so, where you have 2 electrons that are right next to each other. I like to draw it this way because this helps me remember that these 2 electrons are in an orbital with each other. All right, so this is how I'm going to draw my atoms going forward. Now, like I said, helium's pretty easy. We're already done drawing helium. All right, let's move on to oxygen. All right, a little bit more complex. Again, 8 is that magic number here that tells me I have 8 protons. It also tells me I have 8 neutrons. It also tells me I have 8 electrons. So let's go ahead and start with my first electron shell here. Now again, looking at my information, I can see that the number of electrons in that first electron shell is 2. All right, so I'm going to add in my 2. Now that's all that first electron shell can hold, so I need to add in yet another electron shell because I need to get to that magic number 8. So let's get that other electron shell out there. All right, now I know I need 6 more electrons, all right, to equal 8 total for oxygen. So if I look at that second electron shell, I see for my second one, we can hold a maximum of 8 electrons, right? Now I know because there's 8 electrons, there's going to be 4 orbitals, right? This tells me how many maximum that each electron shell can have. If I take that number 8 divided by 2, which is the maximum number of electrons in an orbital, I get 4. So I know I will have 4 orbitals. All right, so for oxygen, I'm going to start drawing in those electrons, and I'm going to put one electron into each of my 4 orbitals. All right, so I'll add my first electron in that first orbital, second one in the second orbital, third one in that third orbital, and fourth one in that fourth orbital. So far, we have 6 electrons total for our oxygen. I know I need to get to 8. So I need to add in 2 more electrons. And to add in the next 2 electrons, I'm simply going to start filling those orbitals up. So my next one, I'm going to add it next to that electron up there and fill in that first orbital. I'm going to fill in that next orbital by adding in my second electron. Now notice that 2 of these orbitals are not filled. That's okay. Right? They're still an orbital. They just don't have the maximum number that they could possibly hold. And for oxygen, right, that's not an ion. This is the configuration that it will be in. We're not going to fill those 2 other orbitals. All right, great. We have oxygen taken care of. Let's do one more molecule, or excuse me, element. All right, molecule would be more than one atom. We're just looking at one atom. So let's look at sodium. And again, sodium, we're looking at that atomic number, which is 11. And so for sodium, I know I'm going to have 11 protons. I'm going to draw those in here, right? I would also assume that sodium has 11 neutrons. Now, sodium is one of those weird ones, all right? Sodium actually has 12 neutrons. Because I know this, I'm going to put in 12. But I would not assume that you knew this, and if you had drawn 11 neutrons as well as 11 protons, I would not mark you incorrect for that. All right, so I have my nucleus done, I have my protons, I have my neutrons. We got to start on those 11 electrons. So let's start with that first electron shell. Again, I can know it holds up to 2 electrons, so I'm going to draw in those first 2. I need to add another electron shell. I know this one can hold up to 8 electrons, and for sodium, we are going to fill in all 8 of those electrons, but still I'm going to do it in that same way that I filled them in for oxygen, that same order. So I'm going to first add 1 into each orbital. Now I'm going to add in my additional ones and fill in the orbitals. All right, so we have 10 electrons total here. We need to add 1 more, which means we need to add in another electron shell, all right? And if I look at my diagram, I see this electron shell could hold up to 18 electrons. I only need to add in 1, so that's a simple one. I'm just going to add my 1 in my electron shell. Now, if I had asked you the question, how many orbitals does sodium have? I can count these up and say there is 1, 2, 3, 4, 5, 6 orbitals. All right. Now, if I look at the information on the side here where it says electrons equal 18, if I divide that by 2, that's 9. So I know I could have 9 orbitals in that third electron shell. But for sodium, we simply do not have enough electrons to fill up all 9 of those. Thus, we will not have 9 orbitals in that third electron shell for sodium. All right, so that's our sodium molecule. I hope that this has made a little bit more sense and cleared up any confusion. I have linked this video here. It's a great video. I love Hank Green. He kind of lays things out in an easy way to understand. He goes over orbitals in this video, but it's concepts that I will not be testing you on. So if you're interested, take a look.